In this problem, we're told that the switch in the circuit blow opens at t equals 0, and use Laplace transforms to find v0 of t for t greater than 0. We're going to utilize our problem-solving strategy entitled Laplace transform in transient circuits. And step 1 says assume the circuit has reached steady state before a switch is moved, and draw the circuit value for t equals 0 minus, replacing the capacitor with an open circuit. So here's our circuit for t equals 0 minus, and we need to find the voltage across the capacitor. Let's do a source transformation on this part of the circuit. And when we do that, here's what the resulting circuit will be. Our current source will have two 6 kilo ohm resistors in parallel on that side of V0. So there's our circuit. Notice that we've got 3 resistors in parallel, 2 current sources in parallel, and we can combine all those down to the following circuit. The 3 6 kilo ohm resistors in parallel becomes a 2 kilo ohm, and the 2 current sources in parallel are both pointing up, so they add together to give us a 3.5 milliamp source. So our initial capacitor voltage is 3.5 milliamps times 2K, or 7 volts. Now, the next step says draw the circuit for t greater than 0 and write the appropriate equation, integral differential equation. Let's apply KCL at that top node to come up with our equation. So for the capacitor, we use I is equal to C dV dt. So we have 2.5 times 10 to the minus 6 dV0 dt plus V0 over 6,000 is equal to 2 milliamps. So there's our equation. Now step 3 says apply the Laplace transform to this equation, and when we do that, we'll have 2.5 times 10 to the minus 6 times S V0 of S minus V0 of 0. That's the Laplace of the derivative. Then we have V0 of S over 6,000 is equal to 2 times 10 to the minus 3 over S. And let's remember that we calculated 7 volts for that. So now we've applied the Laplace transform. And step 4 says, well, now solve for V0 of S. So if we go in and get the coefficient of V0 of S as 1 times S, we can rewrite this equation for step 4 as S V0 of S minus 7 plus 66.67 V0 of S is equal to 800 over S. Okay, so there we're cleaning up terms and rearranging. So now we get S plus 66.67 times V0 of S is 800 over S plus 7. And let's see, we can write this as S plus 66.7 V0 of S, 7S plus 800 over S. So then V V0 of S is 7S plus 800 over S times S plus 66.67. So that completes step 4. Step 5 says, well, perform the inverse transform to find the response. So for step 5, we have V0 of S is 7S plus 800 over S times S plus 66.67. The partial fraction expansion for V0 of S is K1 over S plus K2 over S plus 66.67. So K1 is 7S plus 800 over S plus 66.67. So we multiply through by S, and then let S equal 0. We get 12 for K1. For K2, we multiply through by S plus 66.67. So we have 7S plus 800 over S. Evaluate S equal minus 66.67. So we have 7 times minus 66.67 plus 800 over minus 66.67. So K2 turns out to be minus 5. So now we've completed our partial fraction expansion. So we have V0 of S is 12 over S plus minus 5 over S plus 66.67. So V0 of T then is 12 minus 5 e to the minus 66.67 T U of T volts.